Hey, welcome back to another podcast. This time we've got Frank Nietzschel as our guest. And Frank, welcome.
Oh, thanks, Tim.
So our most successful webinar series, EMC Best Practices webinar series was yours. So congratulations.
Thanks for that. That was correct. A lot of participants.
So not only live, but recorded. We saw a lot of people watching recorded. And so for the viewers, we will link that webinar below. This discussion does not replace that. So please, if you'd like to go back and look, we're going to kind of summarize and answer some of the frequently asked questions. But if you've missed that and you're watching us on one of our video platforms, there should be a link below. So feel free to jump out, go look at that, and come back. So first of all, Frank, that webinar is still current, right?
Yeah, that's current, yeah, because we talked about the latest change in the burst and surge standard. And in the meantime, there were updates. They're still valid. Yeah, that's correct. Just
being around EMC, I'm not a IEC expert at all, but I remember people just talking about edition 2 and edition 3. But when we're talking about edition 2 and 3, we're talking about more than one standard, right? We're talking about a couple of different standards, aren't we?
Yeah, it's we had the change from the burst edition 2 to edition 3, as well as from the surge from 2 to 3. So we were talking about both standards.
And those are more or less on the same update schedule. That's why they kind of get lumped together, right?
They have different maintenance cycles. Maybe the period is similar. It's roughly 3 to 4 years, but there's a time gap of 2 to 3 years between them.
Okay, and these obviously these standards we cover is a part of what the compactNX series does, right?
Yeah. The compactNX is a compact generator which covers a lot of different standards, but the most popular tests are burst and surge.
Yeah, sure. Yeah, I mean, what we talk about today is just not the only things that the compactNX series does. Can we talk about the standards? I remember from your webinar that it all started back in '95 with the first edition, right?
Yeah, it's a long time ago. Yeah.
Yeah. I mean, we're both kind of old hands at this world, but even I wasn't hired in '95. I didn't start till '97. The first big update, when was that? That was in 2004, and that's what we're calling edition 2, right?
Yeah, that's correct. Yeah. We had the 95 or 96 with edition 1, and 2004 we got the edition 2 from the burst standard.
Okay, so and then the edition 3 was
2012.
12. Okay, and can you just summarize? I mean, in a short couple of bullet points, what did they update in 2012?
In 2012, in comparison to the edition 1, there were a lot of updates. The biggest point was that they in the old standard they specified the pulse just at the 50 ohm output.
Okay.
And the pulse shape, pulse energy at the output of the coupled network was completely not specified. So we calibrated the 50 ohm output with a 50 ohm load, and that was it, done. In the newer version, we have to calibrate the 50 ohm output with 50 ohm plus 1000 ohm, not a big thing. But we also specified the output at the coupled network. And the coupled network, you have to calibrate with 50 ohm, and you have to test in a so-called common mode. So in the old users of the equipment know that they have to test, or they tested the lines L and LN or LNPE and all the different combinations. But with edition 2, we changed to common mode, which would mean all lines simultaneously. And the two main issues was that we got a specification of a pulse shape. Mm-hmm. So we had to increase the rise time. It needed to be fulfilled the 5 nanosecond specification. And we had roughly 20% more energy because of the corrected amplitude at the output.
Oh, okay. So it wasn't until edition 3 that we were really calibrating at the output of the CDN. I could see where that's edition 3, right?
No, that started from edition 2.
Edition 2. Okay.
Yeah. The main topics from edition 3 was that they changed the pulse shape for calibration, because all guys know that it's a 550 nanosecond pulse, but this is the pulse shape, and this is how it was specified in the edition 2. But from edition 3, they changed the pulse shape to 5.5 nanosecond rise time for calibration only. And they also introduced the calibration of the capacitive coupling clamp. No idea why, honestly, but that's how it is. So we have to use today a so-called transducer plate for calibrate the passive coupling clamp.
Right. And I remember during your presentation, you were talking about the reduction when doing the verification. That's just because it's kind of like an attenuator, but it really is a voltage divider, isn't it? Yeah. Okay.
Yeah.
That makes
sense. A lot of people that problem to understand it. If you are using a 50 ohm calibration, we have a divider inside, it's 100 to 1. So if you calibrate it, let me say at 2000 volt, you expect with a divider 100 to 1, it would be a 20 volt at the output of the calibration resistor, but that's not correct, because the burst generator has a 50 ohm output, the calibration resistor has a 50 ohm input, so similar for the output of the resistor and the input from the oscilloscope. So we have a divider in total of 400 to 1, so it is 2 kV test level. You can expect a 5 volt signal at the oscilloscope.
Okay, that makes sense. And the other kind of big change, I remember you were talking about. You said something like the burst frequency is now 100 kilohertz, which is closer to reality, but it's optional. How does that? I didn't understand really. Is it actually optional? Are there standards that require 100 kilohertz? How does that all come together?
Yeah. So in the previous standard, we had the specification of 5 kilohertz for the so-called spike frequency. Right. This is a pulse. The pulse is in the burst package, because burst pulse come always in the package. So, and this was changed to 5 or 100 kilohertz. So if you select 100 kilohertz, which is closer to reality, you need to minimize the width of the burst package. So the energy isn't changed. So we always use 75 pulses in a package.
Okay, and so go ahead.
It's up to you. You can select whether you would prefer 5 or 100 kilohertz. You should use 100, and it could happen that a product standard specify that you should use 5. So both combinations are specified in the new standard.
Understood. So it's really the product standard that would tell you definitely if you have to do 5 kilohertz or 100 kilohertz. Interesting.
Correct, yeah.
Okay. Okay. Did we miss anything on burst? What about surge standards? Now I remember you talk quite a lot about the surge standards also.
That's correct. Yeah.
What are the highlights there?
The main topic there is that the pulse shape is changed. In the old standard, we had 2 different standards, two different types of pulse specification, and both was valid. In edition 3, we changed this to just 1, which differs from both previous specifications. That was the main topic. Another big topic is that they changed the tolerances for coupling networks, because we have to calibrate the pulse at the output of the coupling network, there where you connect your EUT. And if you use a couple network for higher current, you have different tolerances. And this leads to that you need to have a couple network with a switchable current range. If you would like to cover the complete current, let me say up to 200 amps, you have 4 different current ranges.
Yeah, I remember now. I saw some launches. So we have like a selectable current range CDN now, don't we? What's that called?
Yeah, we have. What?
What's that called? That flexible coupling network?
No, it's not flexible. It's just a couple network with a current range switching.
Oh, okay, so switchable. Yeah.
Switchable. Yeah.
And then what's this about this 18 microfarad capacitor? I remember that from the webinar also.
Yeah, if you want to calibrate it, you need to use an 18 microfarad capacitor. In our device, it's integrated, and you can just enable or disable it. You need to use it from edition 3 on. You need to use it if you test surge on shielded cables. This was not specified in the old standard, but in the new one.
So it's used during calibration or during testing with shielded cables.
Correct. Yeah.
Okay.
Yeah.
Interesting. And so the other changes were mostly about like the test setups and verification and things like that, right?
Yeah, this test setup isn't changed significantly but the verification, especially for the CDNs with a higher current.
Okay. Okay. And you mentioned also briefly edition 3.1, but also that edition 3 was the actual one. I think some of the people were a little bit confused about that 3.1 versus or edition 3. Is there a 3.1 edition?
There is a 3.1 from the Surge, but with no significant changes.
Okay. So,
we forgot one point to mention. What is important for the users, because another big difference between the old and the new Surge standard is that the pulses at the couple network for data and signal lines, so for these interconnection lines,
all right.
Now we have to calibrate the pulse shape as well at the EUT connector at these types of CDNs, and this was not specified in the old standard. So in fact, it will mean that you cannot use any longer CDNs for shielded cable, for data and signal lines. So you need to buy a new one to be compliant to edition 3. All
right, so that's a really good point, and that brings us to really our number one question we got from several users. So if I have equipment, the people asked if they have equipment that was made for edition 2, can they use it for edition 3?
Surge or burst?
Both. Explain.
So from burst, if it is according edition 3, you can use it for edition 2 as well.
Okay.
If similar to Surge, so if it's according edition 3, you can use it as well as for edition 2, but not vice versa. So the Surge edition 2 is not according edition 3. So there's a difference.
All right. So, but back to your couple network discussion. So not only the generator, but also the couple network changed for both of the standards, or just for the.
Yeah.
Okay. Great. Well, that makes that clear. So basically, if you have equipment that was made for -2, you probably will not be compliant for -3. But if you have equipment for -3, it can be used for -2.
It can be used. Yeah.
Okay.
Yeah. It can be used. Yeah.
So the next question. So you talked about revision 2 quite a lot. Are there cases where people might or should still use revision 2 of the standard?
Yes, there are. That's a good question, Tim. We have cases where customers still need to use edition 2, because if they have a product standard with a dated link to the previous 2 standard, then they have to use edition 2 generator. And it is possible that we deliver a device with 2 types of different calibration certificates, one according edition 2 and one for edition 3.
Interesting. So okay, now it all makes sense. So if the product standard still referred to the old standard, you use the old standard. That makes it clear now. That makes it clear. I do remember, just a funny aside, that you talked about some of the older generators, I think it was burst generators, that used a spark gap or defined a spark gap. Did we actually use a spark gap in the generator?
No, of course not.
I didn't think so.
No, that was in the 90s, where we didn't have the semiconductor switch for making the burst pulses. But in the very beginning, we used the spark gaps, but it was a mess to use, because you have these burning parts on the electrodes. And I can remember there was a very old Schaffner generator, NSG 225, if I'm right, where you could use some cleaning tool with which you have to switch between the electrodes just to clean the surface to get proper impulses again.
Oh my goodness. But we haven't done that in a generation, right?
No, for sure not. We changed to the electronic switch in I think it was 1990, I guess. So it's
okay.
It's a long time ago.
Yeah, I was just starting college in '90, actually. I think we've covered all the topic. Any last things that maybe we missed or you'd like to talk about, especially, Frank?
Nope, think that's it at the moment.
Oh, all right, then I would like to thank you very much for the time. I think I'm not an IEC expert, but so probably I'm still confused. And as a good friend of ours used to say, but I'm confused on a much higher level. So thanks. Thanks a lot, Frank. Thanks for your time. And thanks for watching, everybody. Be sure to click the link below if you're watching on one of the video platforms and check out Frank's awesome webinar series. Thanks a lot. Thanks again.